Hello and greetings to everyone. We have the following questions to answer. Question 1 says PQRS is a rectangle. PQ is a line segment with equation y equal to 3x minus 7 and R is the point 6, negative 1. The x coordinate is 6, y coordinate is negative 1. Find the gradient of the lines PQ and QR. The equation of the line QR. The coordinates of the point Q, that means the x and y coordinates. Let's take down solution. First, for us to answer this question, we are going to start by drawing the rectangle PQRS. Let's assume this is the rectangle. The rectangle is a plane figure. This is our rectangle. This is our rectangle P, Q, R, S. So we have been told that the line PQ has equation y equal to 3x minus 7. This line PQ. We have been told that this line has equation y equal to 3x minus 7. And the point R has coordinates 6, negative 1. This point R, that means the x coordinate is 6 and the y coordinate is negative 1. This is what it means. We are not saying this is how the rectangle looks like. This is just a representation of it so that we can easily answer the question. So now we have to find the gradient of the lines PQ and QR. This is question 1. He says we should find the gradients of the lines. We know equation of the line PQ, equation of the line PQ. Equation of the line is y equal to 3x minus 7. Now we know that the equation of a straight line, the general equation of a straight line, the general equation of a straight line is y equal to mx plus c where m is the gradient. This m here is the gradient, and c here, this c is and c is the y intercept. Let me give it as a point 0, C and such is the y-intercept. That means where this line cuts the y-axis. If we are to draw a pair of coordinate axes, this is the origin where we have 0. This horizontal line is the x-axis. The vertical line is the y-axis. So if we have this our line, let's assume the line is as such. Here, at this point where the line cuts the y-axis, here, let's assume this is the equation of the line y equal to mx plus c. At this point where the line cuts the y-axis, here x is 0. If you put x here, if you replace x with 0, m times 0 is 0, y will be c. So this is our y-intercept. Now, for us to find the gradient of this line, first thing, we need to compare the line y equal to 3x minus 7 with the general equation of a straight line y equal to mx plus c. Comparing y equal to 3x minus 7 with the general equation of a straight line y equal to mx plus c, comma, we have so when we compare, y remains y, this is x, we have m to be 3. We are going to conclude, therefore the gradient of the line PQ, therefore the gradient of the line PQ is 3. Next, we are to find the gradient of the line QR. You can see this is the line PQ. This is the line QR. You can see these two lines are perpendicular. This is a rectangle, so these two lines must be perpendicular. That means they meet at an angle of 90 degrees. Now, we know that if two lines are perpendicular, that is, they meet at an angle of 90 degrees, if you take the product of their gradients, the product must be equal to -1. Now, let me just put a star here. If I take 2 star, I'll write it as such. We know PQ, the line PQ is perpendicular. This symbol stands for perpendicular. That means they meet at an angle of 90 degrees. Is perpendicular to QR. Now we are going to say, let M1 to be equal to the gradient of the line PQ. M2 to be equal to the gradient of the line QR. Next, we know PQ perpendicular to QR if and only if we take the product of their gradients, M1 times M2 is equal to -1. That means if you take the product of the gradients of two lines and you obtain -1, the two lines are perpendicular. If two lines are perpendicular, the product of their gradients must be equal to -1. So that's why we are making use of this symbol. Now if you take m1 times m2 is equal to -1, then we know m1 is the gradient of the line PQ. m2 is the gradient of the line QR, which we are looking for. If we make m2 the subject formula, m2 will simply be equal to, we are going to divide all through by m1. So this will give us -1 all over m1. Let me do it here. If you take m1 times m2 go to -1, we want to make m2 the social formula. We're going to divide all through by m1 because we don't need m1 here. m1 will cancel m1. We'll be left with m2 equal to -1 over m1. This will give us m2 to be equal to -1 all over. We know m1 is the gradient of the line PQ, and we are just from calculating the gradient of the line PQ. We calculated the gradient of the line PQ, and it gave us, we obtained 3. Here, that is m1 is equal to 3. Here, I will simply just replace m1 with 3, and this will give us the gradient of the line QR to be -1/3. Conclude, therefore, the gradient of the line QR is -1/3. Underline the result. We can verify. If we take, we know the gradient of the line, m1 is 3 over 1 times -1/3. This will simply give us, we know 3 will cancel 3. 1 times -1 will give us -1 all over 1, which is equal to -1. It proves that the two lines are perpendicular. Take note. Then we know if two lines are parallel, then those two lines, they have the same gradient. Now let's go to question C, to question B. We are done with A. Question B, it says the equation of the line, the equation of the line QR. Now for us to get the equation of the line, first we know the gradient of the line m2 is equal to -1/3, and we have been given a point R. The point R, we have been given the coordinates of R as 6, -1. We can find the equation of this line. For us to find the equation of this line, we know this gradient m2, we know gradient of a line, gradient of a line is given by change in y, change in the y-axis all over change in x, change in the x-axis. We know our gradient here is m2. m2 will simply be equal to, we have been given a point in the line QR. We have been given the coordinates of that point. So this will give us a change in y. The change in y here, we are going to make use of an arbitrary point. That means any point on that line. Let's assume this is the line. Just assume this is the line. Then this is our arrow. This is our arrow, which has the coordinates 6, -1. Then we are going to take an arbitrary point here on that line. This is the line point which has the coordinates xy. For us to get the gradient, this will give us y minus y1 all over x minus x1. This will give us m2. We know m2. I'll replace m2 the value of m2, which is negative 1/3. Negative 1/3 will simply be equal to y remains y minus y1. y1 is simply the y coordinate of the point arrow, which is -1. We must put the negative sign all over x remains x minus x1, which is the x coordinate of the point arrow, 6. This will give us negative 1/3 to be equal to, when we have two negative signs, it becomes positive, y plus 1 all over x minus 6. Next, we can decide to cross multiply, or we multiply all through by the LCM. We cross multiply. This will give us negative 1 times x minus 6 to be equal to 3 times y plus 1. Next, we are going to make y the subject of formula. We are going to expand the left hand side. -1 times x, which gives us negative x. -1 times -6, which gives us positive 6, will be equal to 3 times y, which gives us 3y, plus 3 times 1, which gives us 3. Let's write it down. This will give us negative x plus 6 is equal to 3y plus 3. We have to make y the subject of formula. We are going to send 3 this way. This will give us negative x plus 6. 3 becomes negative 3, equal to 3y. This will give us negative x. 6 minus 3 gives us positive 3, is equal to 3y. Next, we are going to divide all through by the equation of y, which is 3. This will give us negative x plus 3 divided by 3 to equal to 3y divided by 3. This and this will cancel. We are going to obtain negative 1/3 x plus 3 over 3 is equal to y. Remember, if we have a fraction, a plus b over c, this is the same as a over c plus b over c. So this is simply what I have applied here at the left hand side. This will give us negative 1/3 x plus 3 divided by 3 gives us 1 is equal to y. We are going to obtain, this will give us y to be equal to negative 1/3 x plus 1. We are going to conclude, therefore, the equation of the line, your arrow is y equal to negative 1/3 x plus 1. I will underline the equation of the line. Next, question C. We are going to question C, which says the coordinates of the point Q. When we talk of the coordinates of the point Q, that means the x and y coordinates. We are going to start by saying that let x1, y1 be the point Q. That means the x coordinate of the point Q is x1 and the y coordinate of the point Q is y1. Next, we know the equation of the line. We know the line PQ has equation y equal to 3x minus 7. We know the line QR has equation y equal to negative 1/3 x plus 1. You'll see that in these two lines, the point Q is common. That means these two lines, if you look at this our rectangle, you see that the two lines, the lines PQ and QR, they meet at the point Q. So that means the point Q will satisfy these two systems of equations. That means if I replace y here with y1 and x here with x1, the system will be true for the two lines. If I take the first one, substituting, alright, this substituting x1 and y1 in the two equations, we have the first one, we are going to obtain y1, the equation of the line PQ. We're going to obtain y1 to be equal to 3x1 minus 7, and next we are going to obtain y1 to be equal to negative 1/3 x1 plus 1. We are going to obtain these two equations. We call this one equation 1, we call this one equation 2. y1 is equal to 3x1 minus 7. y1 is equal to negative 1/3 x1 plus 3. It simply means that the right hand side of the first equation is equal to the right hand side of the second equation. So we can equate these two. That is 3x1 minus 7 be equal to negative 1/3 x1 plus 1. This is what we are going to obtain. This will give us 3x1 minus 7. I will transfer negative 1/3 x1 to the right hand side, which becomes positive 1/3 x1. So this will be equal to 1. Next, I will transfer negative 7 to the right hand side, which becomes positive. This will be equal to 1 plus 7. We know 3 here is the same as 3 over 1. We'll be adding 3 over 1 plus 1/3. We find the LCM. The LCM is 3. 3 divided by 1 gives us 3. 3 times 3, 9 plus 3 divided by 3 gives us 1. 1 times 1 remains 1. This will give us 10 over 3. So this will give us 10 over 3 x1 is equal to 1 plus 7 gives us 8. We know 8 here is over 1. Next, we are going to multiply all through by the LCM of the denominator of the fraction at the left hand side and the denominator of the fraction at the right hand side. You know the LCM of 3 and 1 is 1. So we can easily just say we will cross multiply. This will give us 10 x1 to be equal to 3 times 8. You know 3 times 8 will simply give us 24. Next, for us to get the value of x1, we are going to divide all through by 10, the coefficient of x1. This will give us 24 divided by 10. 10 will cancel 10. This will give us x1 to be equal to, we can further simplify this. This will give us, we know 2 will go into 24, 12 times, and 2 going to 10 5 times. We can express this, we can write this down as a mixed fraction. This will give us x1 to be 2. The whole number part will be 2 because when we divide 12 by 5, we are going to obtain 2 remainder 2. In the remainder which is left, 2 is to be divided by 5. So this is the value of x1. Next, now we need to find y1. For us to get y1, you can decide to make use of equation 1 or equation 2. Using equation 1, that is, equation 1 is y1 equal to 3x1 minus 7, comma, putting x equal to, x is this mixed fraction which is the same as 12 over 5. We have, so anyway we see x, we have to replace x with 12. It is 12, not 15. 12 over 5. This will give us y1 to be equal to 3 times, I'll replace x1 with 12 over 5. This is x1 minus 7. This will give us, 3 times 12 will give us 36. This will give us 36 over 5 minus 7 over 1. Next, we have to find the LCM. The LCM of 5 and 1 is 5. 5 divided by 5 will give us 1 times 36 minus, we are going to bring down the negative sign. 5 divided by 1 remains 5 times 7 gives us 35. Next, if we subtract, 36 minus 35 gives us 1 over 5, so gives us y1 to be equal to 1/5. Here we can put therefore, comma, the point Q is the point Q. The x coordinate is the mixed fraction 2 and 2/5, and the y coordinate is simply 1/5. We underline point. And we are done. Question 2. Question 2 says the sum of the first n terms of a progression is given by Sn equal to 2n squared minus n. Find the sum of the first 6 terms. We have to find the sum of the first 6 terms. We know the sum of the first n terms is given by 2n squared minus n. And we know for us to get the first term, we are simply going to replace the sum of the first term, we are simply going to replace n here with 1. For us to get the sum of the first 4 terms, we are simply going to replace n here with 4. For us to get the sum of the first 6 terms, as question A is asking us, we are simply going to replace n here with 6. We have n equal to 6. S6 will simply be equal to 2 times 6 squared minus 6. This will simply be equal to, 6 squared is simply 36 minus 6. This will be equal to 2 times 36 will simply give us, multiply by 2. 2 times 6 gives us 12. We are going to write down 2, we carry 1. 2 times 3 gives us 6 plus 1, we carry 72. This will give us 72 minus 6. X 72 minus 6 will simply give us the number 66. Simply going to obtain 66. So this is the sum of the first 6 terms of that progression. Next, question B says we should find the first 3 terms of this progression. Firstly, we need to find the sum of the first term, S1. The sum of the first term will simply be 2 times 1 squared minus 1, which is simply equal to 2 times 1 minus 1, which is equal to 2 times 1 gives us 2 minus 1. The result is 1. We know when we sum, if we have a progression with terms A, B, C, D, E, the sum of the first term remains the first term. Here, in this case, our first term, which is denoted by A will simply just be 1. So this is our first term. Now, for us to get the second term, we know the second term. I'll write this down. Second term will simply be equal to, for us to get the second term, we are simply going to take the sum of the first 2 terms minus the sum of the first term. That means you simply take the sum of the first 2 terms minus the first term. This will simply give us the sum of the first 2 terms is simply 2 times 2 squared. We are going to replace n here with 2 minus 2. Then we know S1 is simply the same as A. You know, this S1 is the same as the first term. This will be minus 1. This will simply give us, we know 2 squared is 4. 4 times 2 gives us 8 minus 2. This will simply be equal to 8 minus 2 gives us 6 minus 1 gives us 5. So the second term is 5. Next, we need now to get the third term. The third term will simply be equal to, for us to get the third term, we are simply going to take the sum of the first 3 terms minus S2. This will simply be equal to 2 times, we are going to replace n with 3 squared minus 3, then minus S2. We're going to replace n with 2. 2 times 2 squared minus 2, not 3. We are going to obtain, this will be equal to 2 times 3 squared gives us 9 minus 3 minus 2 times, we know 2 squared is 4 minus 2. So this will give us 2 times 9 gives us 18 minus 3 minus 2 times 4 gives us 8 minus 2. This will give us 18 minus 3 gives us 15 minus 8 minus 2 gives us 6. 15 minus 6 gives us 9. Therefore, we are going to conclude, therefore, the first 3 terms, of the progression are, we are going to write down the first 3 terms of the progression. The first term is A, which is 1. The second term is 5. And the third term is 9. So these are the first 3 terms of the progression. I will underline them. And the next part of the question says we should determine the type of progression. So C, we have to determine the type of progression. For us to determine the type of progression, that means we have to determine whether it is an arithmetic progression or a geometric progression. We know for an arithmetic progression, we get the terms by adding a constant. You simply add a constant to the previous term to get the next term. While for the geometric progression, for us to get the terms, we simply multiply the previous term by a constant, which is known as the common ratio. Now, in this case, if we take the third term, 9 minus 5, it is equal to 4. We take 5 minus 1, it is still equal to 4. You will see that 9 minus 5 is equal to 5 minus 1, which is equal to 4. So you will see that for us to get the second term, 4 is added to the first term. 1 plus 4 gives us 5. For us to get the third term, 4 is added to 5. 5 plus 4 gives us 9. The constant 4 is being added to the previous term to get the next term. And this constant 4 is known as the common difference. In this case, we are going to conclude that this progression is an arithmetic progression since there is addition of a constant, which is 4. I'm going to conclude the progression is an arithmetic progression, and we denote an arithmetic progression by making use of A, capital P, and we are done with the correction of the questions. Thank you very much for watching.